All right, so this is a DX demonstration using the Faro teardrop part here. And this is picking up right after scanning. So the idea here is that I place the teardrop part, in this instance, on a coffee cup. I scanned it relative to the arm. You can see it's not aligned. And I have the individual scan passes here over on the left-hand side. And I'll walk through all the steps as to how I do a demonstration with DX from this point forward. And then I'll give you the files of it completed and the start file, and then a start file that has it already aligned. So the first thing I do after I scan is I go ahead and run the scan process. So I have a scan process built for the Faro parts here. So I just select the scan process here. And in order to use those scan processes that I have here, I exported it out, and you can import it in the other dialog here under this stack here. It has design scan process. In that design menu, there's an import feature, so you can just grab it and import the scan process that has all the proper settings for each tool and merges and creates region groups and everything from the get-go. So importing that is under the same stack here. This is the run. There's also the designer, and in the designer, again, lets you import the scan process. So that is in the demo kit too. So now that's finished, you'll see that over here on the left-hand side, you have all the original scans because I told it not to get rid of those. So I'm just going to hide those. And if I click on this drop down here in the upper menu, you can turn it back to just shaded. So that's just the shaded data without seeing the regions. If I want to delete this stuff really quickly and easily, this happens during demos, right? You scan the table or whatever. If it's separated objects, you can use the flood fill tool, right click, inverse, delete. So now I'm also going to come back to the regions and switch back to the rectangle selection tool. To do a basic alignment, if you want to do that alignment in a demo, you'll see here that these, right now, for some reason, in this version of DX, it's labeling all these flat areas freeform. See how if I roll over them, they're supposed to be labeled planes, but they're all coming in as freeform. And in order to select them in the tool that I'm about to use, you have to label them planes in the properties. So when I click on it over here in the properties, you can switch it to plane. That's something that you shouldn't have to do, but right now, that's the way the software is acting. So it's an extra step that you don't really even have to mention. You can just change those to plane. The quickest and easiest way to align it is in the Home tab, Interactive Alignment. Click on the mesh that you want to align to world. Leave it on 3, 2, 1. Click the top as the plane, side as the vector, side as the position. And if you want to just flip-flop the z-axis to make sure it's up and hit OK. Now, if you hit your predefined front view, there you have the part aligned, kind of. It's not the best alignment ever, but this does well for just demo presentation purposes. First thing we're going to do is create the outer shape of the whole part. And we're not going to model the whole thing. I usually like to show about 3 different things. So I'm going to click on that top plane, go right click, go to mesh sketch, and then create a silhouette of this top surface. Sometimes this happens in the newer version of Design X where it doesn't automatically target a mesh because it doesn't know which one to grab. So you have to click on the mesh either in the graphics window or in the tree to tell it which mesh to create a mesh sketch for. So if I go ahead and silhouette that a little bit on the top and hit OK, I'll just hide my mesh by turning it off over here, or you can use Alt spacebar which will toggle it. That's another shortcut. When I go through the process of modeling this, you can talk about how you can draw things wherever you want. So if I wanted to draw my lines manually, and then you can talk about how you can window in, and if you double click in space and accept the line, or you can talk about how you can just click on the line segment and you can click here, or you can accept the fitting right there. And then in the right click menu, if you get out of the command, you can go to the right click menu and select line again. I like using the double click in space. You got to double click pretty quick in order for it to work right. And you see in this instance on the side, I'll show how you can just create a line and drag it like that. So I'll usually do something along those lines right there where I rough in the outside. Then I come over and I do a corner trim. Make sure it's on corner. Make sure they're all trimmed too. That's one thing, because sometimes if the endpoints are near each other, it looks like it is trimmed and it's not. If for some reason you want to check that, you can come over to Accuracy Analyzer, Disjointed Ends. So anything that is not connected will have a turquoise end if you run disjointed ends like that. So you'll see two turquoise line dots next to each other in there. So that doesn't always stay on. I set disjointed ends and turn it on, but it's not always persistent. So from there, I like to go ahead and add these two fillets just to show it's possible to do this inside of the sketch. So you can drag those fillets in. And if you want to redimension them, you can, just to show that it's possible again. So you say 11.5 or 25. You can just override those. Now we have our outer shape. So if I get out of the sketch and turn my mesh on, I'll go ahead and do an extrude. And if you're using this part all the time, just remember it's about 40 millimeters. You can just drag it down and do so that way. I like to go ahead and add fillets too, just to show how you can add it in 3D. So if I come over here, you see the last time I did a fillet was huge. So if I just type in 5, on this part it ends up being a 5 millimeter fillet, but you can use this auto estimate from mesh and it will look at the underlying mesh, and it's a really powerful tool for this software, and try to estimate what it should be. And it's never a round number, but you can then round it off and you see that 4.9, that's obviously 5. And then I can add these in if I want to. Go ahead and add the 5 millimeter fillet to those and hit OK. Now, you don't have to model this whole part. Like, we can select that top plane and do a mesh sketch. And we'll turn the solid off. Select that and model that pocket if you want. Just to show how you would do an extrude cut. This does go really fast if you want to. I like to drag out a rectangle and snap it like this. And then most of the time I will do it. I'll drag out the fillet right here. So if I turn that solid on. And one thing that's really neat about the extrusion is you can snap it to the mesh. So you can say, I want to go up to region, hide the solid, click on that region, and you can say up to mean distance. So just average that out. And then usually it gives you, like, you can drag it up and snap it, or you can just go up to the average distance. So you're just extruding it up there, and then I can say cut, and then turn my solid back on. You'll see that it cut it away. Now from here, what I do like to show is how you can model this bulge here, the bump on the teardrop part. To me, it looks like more of a revolution, and you can manually create a revolution and do that and add it to it. But just for the sake of simplicity in doing a presentation, I will use the Loft Wizard because that is one of the most powerful tools in the software anyway. So, this is just going to make an organic shaped loft through that data. And you can see here, I can click on all the regions that I want to include in my surface loft. So I'm going to click on all the ones that are inside of that boundary just to make it very simple on the software to fit that. And then make sure that you extend these out. And you'll see why in a minute. Make sure they go nice and far out. And then I set it to number of sections, 7. And smoothness, I have it all the way down to less. And I have reference planes instead of 3D sketch. Not all those things are critical, but you can just stick to those basic parameters and it does a pretty good job. So when I hit next, it's going to go ahead and create the sketches and preview it. And I have the ability to type in number of points on the spline. So I'm going to put 10 on each one of them and then accept it. So we were able to just extract that really quickly from the mesh, but you'll notice it's still a surface. So what I like to do is use the CAD model, select that top plane, do a surface offset of 1 millimeter in the negative direction. So down 1 millimeter and hit OK. Hide my solid. And I make sure that both of these surfaces completely intersect each other. If this top one doesn't, you can use the extend surface and make sure that it extends. And if it never does and it veers away, then you can go edit the proper cross section and drag it down and make sure it completely intersects. If they do intersect, like this does, if you properly fit that mesh Loft Wizard, you come over to Menu, Insert, Surface, Solidify. Select both of the surfaces. If they form a bounded volume, it will create a solid from them. So you'll notice that it just turned off surfaces. Now I have two solids here. I can just come over to Boolean, select them together, say merge. Now I've merged that in, and then I can fill it. And I usually apply a 20 millimeter fillet to this. If I want to fillet this too, I can do that. I think this is a 5 again. And then I do it in 2 steps like that, where I fillet that one, and then I fillet this one, and I do this one at like a 2, somewhere around there. That's not exactly what's there. You might want to do this instead. Actually do the top, then do the side as a 5, then come back with the 2 millimeter here. If you're really wanting to. It's not exactly what's there, but that's a simple way to do it. So once I get to this point, now comes the part where I make it a sheet metal part by using the shell tool. So if I come over to shell, I tell it that I want to use this body, and I select what faces I want to remove. So obviously the bottom, but also I want to remove the sides. And be careful you don't select anything like this right here. I accidentally clicked on that. I do 2 millimeters on this part. So now I just created a 2 millimeter sheet metal part. And if I have time, I'll go ahead and go to the top, select my mesh again. There we go. Silhouette, and I'll cut those holes. These, again, they go really fast. If people are interested in seeing how it's done, you can just best fit these 2 slots. Accept that. Come over to circle. Turn on my solid. Extrude. Cut. Mid-plane. And then, like, there's more because the sides actually are cut away, but usually this is enough to show people how the process works. And then if I come over to Accuracy Analyzer and I turn on Deviation from Body, I took a lot of liberties with the part, so it's going to have some deviation here, but it's nice to show that you can run a deviation from the CAD body that you modeled back to the original scan data just to see how closely you followed it. And then you can make decisions as to whether that's what you want or not. But this is just to give you a form of feedback to make sure that you're extracting the model that you want to send downstream to manufacturing. So that is a Faro teardrop demo.